Okay, today we're going to have a look at energy profile reactions, and we are going to look at the difference between exothermic and endothermic reactions. So the first thing that we need to understand when looking at these is we need to know what these energy profiles are actually telling us, and you need to be able to remember them, you need to be able to draw them, and you need to be able to refer to them in the exam. So we'll start off by looking at the exothermic reactions first of all. So your energy profile diagram basically shows you the energy of the reactants and the products. The R here stands for reactants and the P here stands for products. And what happens is, in order for any reaction to occur, first we have to break the bonds. So this part of the arrow here, or the line, is showing us the energy that's being required to actually break the bonds, because breaking bonds requires you to put energy in. So this is why the energy level is going up here at this particular point. Once you've broken all of the bonds, you then need to start making the bonds. So then, once the bonds are broken, all the atoms are individual, we then start making the bonds, and that's this part coming back down here. Now, making bonds gives out energy. So that means that the energy level of the reaction is now going down because the energy is being given out to the surroundings. Overall, we can look at the main change that's happening here as we go from reactants to products. So if we look, let me just change my colour, at this level of reactants here and the level of products, we can see that overall the energy level went down. So our products have got less energy than the reactants. This is known as our enthalpy change, and it has the symbol triangle H. So triangle H is our enthalpy change. Because the energy level's gone down, that energy's had to go somewhere, and so that energy was given out to the surroundings, and that means that the surroundings will get hotter, making anything in the area increase in temperature. So if that was a solution, the solution would get hotter. The easiest exothermic reaction to think about is a combustion reaction. So you burn the reactants. When the products form, energy is given out. So overall, energy is given out here. There's one other thing that we can label on this diagram, and that is the activation energy, and that goes always from the level of the reactant to the top of the hump, and it's often symbolised EA, and that's the activation energy. This is the minimum amount of energy required to start a reaction. So that's the energy you have to actually put in to break the bonds. So let's apply this information then to an endothermic reaction. So endothermic reactions also have activation energy, and again it always goes from the level of the reactants to the top of the hump. But endothermic reactions are a little bit different. This time the energy required for breaking and making is in different amounts. So we see that overall energy gets taken in rather than given out. So we still start off with our reactants, and the bonds in the reactants have to be broken first. So as those bonds are being broken, that means that we're having to put energy in at this point. So the energy level of the reaction is rising. But once those bonds are broken, again, we need to make the bonds again afterwards. And so we come down here, and now we are making the bonds. And remember, making bonds gives out energy to the surroundings. But it's not as much this time. That amount of energy here that's given out when making the bonds is not nearly as much as what was taken in here when we broke the bonds. So more energy has actually been taken in this reaction. That means that this reaction is going to get colder overall because that energy has been taken from the surroundings. So although there's been an energy rise here, in other words, the products now have more energy than the reactants had in the beginning, the actual surroundings are getting colder because the energy is being taken away from the surroundings in order to break these bonds. That energy has been effectively used up. Imagine you are holding something and it's taking energy away from your hand. How is your hands going to feel? They're going to feel cold because the energy is being taken away from it. Whereas if you think about the exothermic reaction, if you was holding something that was giving out heat, your hands would feel warm. So always think about you're holding something absorbing or giving out energy, and that will help you think about the corresponding change in temperature that goes with it. So overall here, energy is taken in. Now the important thing to remember when you're explaining these sorts of diagrams in an exam is to remember that in all reactions, bonds must be broken first and bonds must be made afterwards. It's not a case of exothermic only makes bonds and endothermic only breaks bonds. Both things happen in both reactions. What is important is the amount of energy used for one process over the other. So in exothermic, there's less energy taken in to break bonds, more energy given out to make bonds. In exothermic, more energy is taken in to break bonds, less energy is given out when making bonds. So remember, this one gets cold and this one gets hot. I'm going to scan in a sheet that summarises this for you as well, but hopefully that explanation has made things a little bit clearer for you.